Hi, everyone. This is Aaron Larson, executive editor of Power Magazine, and you're listening to the Power Podcast. On today's episode, I'm joined by Anna Lafayanis. Anna is the program lead for the integration of renewables and co-lead of the Get Set initiative with EPRI. So, Anna, thanks for coming on the program. I've also got Ted Block-Rubin, who is Director of Business Development with SmartWires. We're going to be talking about grid-enhancing technologies. But first, Anna, why don't you tell a little bit about yourself and what you do with EPRI, and then we'll have Ted do the same.
Thanks, Aaron, for having me. And I'm excited to talk about Get Set and what we are doing at EPRI. But before that, just so you all know a little bit about me, my name is Anna Lafayanis. I've been working in the power sector for over 15 years. I'm based in Toronto. That's in Canada. So if you hear an accent, just chuckle away. I spent most of my career as a system operator. I focused on planning for the future, so understanding what reliability needs we have, how to integrate emerging technologies. So previously focused on storage, demand response, and the incentives that are needed for that. Over the last couple of years, I've been able to take that kind of passion into overdrive at EPRI. So today, what I work on is looking at that reliable integration of renewables, but also other technologies. And grid enhancing technologies are one of those really fascinating enabling technologies for this. Before I hand it over to Ted, I figure some of your audience might not know about EPRI. If they've been sleeping for the past 50 years, we've been around since 1972. So we're an independent, objective, nonprofit energy research, development, and deployment institute. That's a mouthful, but really what it means is that we tackle research a little differently than other research institutes. First of all, we are an applied research organization. So we work hand in hand with utilities and energy companies. The second thing that's kind of unique about us is that we're really connected to being collaborative. It's at the heart of everything we do. We are a global institute and we have been global from the very beginning. And the third part, and this is probably the most important part, is that we pride ourselves on being unbiased and objective. So in doing so, we are trusted as a really credible source of truth.
Yeah, we rely a lot on EPRI. We get a lot of great input and research from your group, and I really appreciate you being here to talk about grid enhancing technologies. So Ted, would you please tell a little bit about yourself and SmartWires?
Sure, happy to. And again, echoing Anna, thanks for having us. So my name is Ted Block-Rubin. I'm a director of business development for SmartWires. I've been with the firm a little over 8 years now. I'm actually a mechanical engineer by training, and then I played around in the clean energy transportation space for a couple years. Went back to school with what I call something of an interdisciplinary master's degree in sort of almost engineering that had some energy law classes, some project development, project finance. But that's actually where I was introduced to SmartWires, where funnily enough, 9 summers ago, I started as an intern. And I think what I've learned in the time is, this was again almost 10 years ago when everyone was talking about renewables and storage and interesting things happening on the distribution and customer side. No one wanted to talk about the grid. The grid was not sexy, and that is for sure how I felt when I started my program. But starting with the company and really interfacing with salt of the earth utility people really sort of trained me on the importance of transmission and echoing the phrase I think Rob Gramlich has made famous now, no transition without transmission. That's really been a big part of my role here at SmartWires, where we are a digital grid solutions company focusing on a product called an advanced power flow controller. The company actually started from a Georgia Tech research lab under the auspices of Dr. Deepak Devan. Our CTO at the moment actually did his PhD on this technology at Georgia Tech, and so there's a lot of long history within SmartWires, and that's probably podcast for another time, but where we're at today is, helping our customers squeeze more juice out of the existing grid, which has never been more important, both on the generation connection and, the conference I'm at today, load connection. And so, being based in Durham, North Carolina, and manufacturing in the US with partners and deploying devices around the world, we're seeing uptake and interest on really helping customers manage really unforeseen pace of change and system conditions that, frankly, an entire generation of utility folks haven't had to deal with. And so it's an exciting time, a challenging time, but I think we're well prepared for it, and we rely very heavily, just like you, Aaron, on the auspices and experience of EPRI. So we're excited to chat today.
Anna, to begin, would you kind of lay out for listeners who may not really be familiar with what grid enhancing technologies are, what are you focused on, and how do they work, and why are they so relevant and important today?
It's a good question. So the simple answer, grid enhancing technologies can be either hardware, just kind of like the smart valves that we're going to talk a little bit about today, or software solutions. And their purpose is to increase the capacity, efficiency, reliability, or safety of transmission lines. So think of these as adders to your transmission lines to make them even better. Typically, they reduce congestion costs, they improve the integration of renewables, they increase capacity, they can provide grid service applications. So they're really multifaceted, very helpful for the grid. At EPRI, we think of them as kind of like a tool in a toolbox. And there's a couple different kind of definitions of what would be considered a grid enhancing technology. Sometimes they're called advanced transmission technologies. There's all these different categories. So I always start with that kind of high level thing because people can take it a few different ways. But at EPRI, there's 4 technologies that we're using to focus on. And these are the ones that we see as very high potential, very close or already at large scale deployment. And those are also featured by the Department of Energy last year in their liftoff report. So it's very much aligned with what we're seeing, especially in America. So those 4, and you've probably heard some of these acronyms before. The first one, dynamic line ratings, DLR. Its purpose is to provide transmission ratings that accurately reflect real-time conditions. They're a little different than some other terms you might have heard of, ambient adjusted ratings, AAR, in that they're looking at wind speed and wind direction, in addition to looking at temperatures at the time, and that allows you to get the maximum transfer of power. The second one that we focus on is advanced conductors. They kind of sound exactly as they are. These are high conductor temperatures that can run on a different type of conductor. So just thinking of using something beyond just a regular steel conductor, and it improves the sag temperature. That way you can run more and at higher temperature. The third one is topology optimization. It is like transmission switching on steroids. It allows you to look proactively and switch equipment in and out to make sure that you are getting as many electrons to where they need to go. I've also heard it called the ways of the transmission system, which I think is a really, really cute way of describing it. And the last one, and the one that Ted knows the most about, is advanced power flow controllers. So the purpose of these is essentially they inject into the grid to direct the flow of power. They are a little different than some of the traditional technologies you might have heard of, phase shifting transformers or PARs, in that they use power electronics. So it allows you to operate the grid with a lot more granularity. It allows it to be more reliable than a traditional technology as well. It's a really, really exciting piece of technology as well.
So, Ted, I'll turn to you, and maybe you can explain a little bit more about the technology that you specialize in and kind of how that weighs into these grid enhancing solutions.
Sure. Well, it's funny. I was sitting in a room of legislators a couple weeks ago, after having sat in traffic between Austin and San Antonio that made me lose my mind, but that's besides the point. And the way I sort of opened was, technologies that have been on the grid are ICE cars, and what we're representing and providing is an EV. And it's pretty accurate because we're using the same kind of guts that, EVs are famous for maturing. The internal power electronics in our device is very similar to what's found in, the latest and greatest. Similar technologies used for HVDC, and really what we're doing is changing the physical characteristics of the transmission circuits that we're installing on, which is a bit of a mouthful, but what it means is we're providing a firm, irrespective of weather and ambient system conditions, change in power flow. And if you think about the way the grid is developed, there are typically lots of circuits that move power from an area of generation or a generation pocket to a load pocket. And what that means is, the system has developed over a number of years, and those distances are slightly different. The type of conductor is different. And that means that those circuits don't share power very well. As a reminder to listeners, power, generally speaking, flows along the path of least resistance. It's not really resistance, but that's not kind of besides the point. And what that means for operators is that their system is generally pretty underutilized. And the sort of mentality of smart wires and the smart valve, which is relatively aptly named, is that we can help utilities sort of ramp up and ramp down specific flow on circuits that we install on, which has knock-on effects for the entire system in that region. So in terms of, broad numbers, some of our projects, again, installed in existing substations, no new permits, no new right-of-ways, have helped ramp up system utilization by, sort of massaging. I often think about it as sort of the marionette holding a bunch of strings, being able to pull up and pull down in smart ways in different system conditions to squeeze more juice across an overall region. We've had projects move over a gigawatt of power without building a single new line, and installed in a matter of 15 to 24 months, let's say, which in comparison to traditional transmission infrastructure would make a planner blush, basically. And that's really exciting. And that speed and control and affordability and flexibility, both in deployment and dispatch, create a whole host of interesting applications that I think are really exciting for planners, for utilities, and certainly for customers who ultimately are responsible for the system. We all pay our bills. We're the owners, whether we realize it or not. And so that certainly motivates me every day.
Mm-hmm. And of course, the reason this is so important is because we're seeing projections where data center electricity consumption is likely to potentially triple needs by 2030, and this amazing growth is something that's going to have to be supported through the transmission system. So from your perspectives, and I guess I'll start with you, Anna, how prepared are the transmission systems and the infrastructure that we have in place to handle this type of load demand and this growth that we're going to potentially see from data centers and electric vehicles and electrification of everything that we have been hearing about for years?
I love this question, right? It's hard to get on a call and not talk about data centers and the potential load growth. And EPRI has done some research, right? So just a couple of facts to put this into perspective of the challenge ahead. AI queries require approximately like 10 times the electricity of a typical internet search. So I don't know how many times you've asked something of Google this morning, but I've probably asked Google at least 25 questions already today, right? That's a lot. And there's 5 billion internet users in the world. So just think of how much that's going to grow. And it's already here, right? If you think of your Metas, Amazon, those other hyperscalers, their electricity load has actually doubled between 2017 and 2021. So already we're seeing this big change. A couple things to consider with it. When we think of data center growth, it's mostly very local, very regional, big data centers in certain spots. And so because of that, it requires this even deeper collaboration than you might have with other types of loads. We're seeing this need for collaboration from between the owners and the developers, utilities, government, all of those stakeholders. And I told you kind of earlier, I always talk about collaboration because that's what EPRI is all about. And in order to get utilities ready, they're seeing this too. They want to see that they're collaborating so that they're in the best position for it. So it's not about necessarily, oh, is the infrastructure ready? It's about making sure that we are ready for the future and working all together. To that end, we actually have an initiative at EPRI called DC Flex, Data Center Flex. And we're bringing together everybody, trying to understand the utility programs, the operational models. That way, the transmission infrastructure is actually in the best position possible. Not just a good enough position. We want to be in the best position possible for this boom in data center and AI growth.
From my perspective, I'm going to throw in a shameless plug here as well, because we're going to be hosting a data center power exchange summit in Denver, Colorado in October 28th, actually. And we just realize how important it is to bring people together to talk about this challenge that data centers presents and how we can potentially, how the power industry can support the data centers and support their customers without having reliability issues and, other problems that these present. So, Ted, from your perspective, what do you see happening, and how is the infrastructure going to be able to handle some of these challenges that we're facing?
Yeah, I was at dinner with some utility folks last night, and there's a lot of talk, and some folks are getting a little frustrated that reality is not being put out on the table. So, places are states like Arizona or California or New Jersey, the pipeline of hyperscaler growth is at or exceeds their current peak demand. And that's insane because that implies that they're going to be able to grow their generation or import capability in the next 5 years more than what has taken, 50 to 100 years to develop. The supply chain of natural gas turbines is backed up. Some priorities might limit the ability to get new generation online. People are talking about small modular reactors and recommissioning things like 3 Mile Island. I think what you're seeing is a scramble and sort of a look of whatever the best options are. It's not a one size fits all approach. And I think that creates a good environment for the work that EPRI is doing, both in DC Flex and in Get Set, to reinforce the need for near-term solutions. The one thing that all these load and hyperscalers have in common is that they're not going to build a gigawatt overnight. There will be phases. And when you have phases, you have the opportunity to allow your grid to develop in line with what's actually being connected in the next 12 to 24 months. Most transmission organizations haven't really been thinking about, okay, what do I do for the next 2 years? Because they live in a regulated world where they need to be able to define what the 40-year need is or the 20-year need is. And so there is a role to play for regulators and legislators to acknowledge, we should be allowing flexible solutions that can solve the problem of the next few years and then still be useful when the system continues to develop. And so that's a bit of where my head is at on this matter.
And of course, Anna, you mentioned there's like 4 different types of grid enhancing technologies that you're focused on and that could provide useful benefits to the system. Smart Wires obviously has their advanced power flow control technology. Are there other solutions that you think offer a lot of promise, or which do you think is going to be the I don't know if there's a silver bullet or not, but is there something that you feel can really make a difference here that that needs to be implemented nationwide or worldwide?
You're right that there isn't a silver bullet. I wish there was. But there's a really good approach of using them in all of the technologies, all the options complementary. Like Ted said, it's a huge amount of growth, a huge value proposition that's in front of us. So we should put everything on the table, and we can see a few types of technologies that work like really well together. And in addition to building new traditional transmission as well. So I like the example of like if you're going to use dynamic line ratings, for example, you can get even more of them. They work on looking at thermal constraints. Well, the other technology that also helps to alleviate thermal constraints are advanced conductors. Can you put the two together to get the most out of the advanced conductors that you're spending money on and making sure that you get the best value proposition? The answer is yes. You should use them in combination, and that would be really, really good. So I'm not going to pick a favorite. I will say that as I've been working on grid enhancing technologies, my personal favorite technology has changed over time as I've learned about each of them and each of their use cases. You just find out more and more cool ways that people think of applying them and different ways to use them. And that's part of the learning, right? There's been a number of pilots over the years, but now as we get to full scale deployment, you start to see it all come together and this potential to use them in many, many different ways.
Mm-hmm. And do certain things work better in different regions? For example, would something that's very useful in California maybe not be as useful in Canada where it's colder, or in some other area where maybe the congestion dynamic is different? Or what do you see there?
So the physics is the physics, right? So the good thing is it stays the same wherever you are in the globe. You're not going to have a circumstance where, one place the physics looks different than the other. But we know that each of the technologies kind of targets maybe a different physical challenge on the grid. So because of that, you kind of look at the site conditions to know which one is going to be better in what condition. You mentioned congestion. That's like a really good one to look at. What is causing that congestion? How much does it cost? What is the cost benefit analysis against some of these technologies? And then you can actually determine which one is right in that circumstance. Unfortunately, there isn't like a rule of thumb for this. You do need to do assessments, and I think that is one of the challenges in front of the industry, is just knowing how to do those challenges, coming up or doing those assessments, how to do the planning framework for it, understanding which technology at which time, and for how long to use it for. So, like almost everything in the power sector, it's always nuanced. It's always an it depends answer. And I admit I'm an engineer by trade, so I'm guilty of always saying it depends. But in this case, at least I said, like, the physics is the physics. You don't have to differentiate between California or Canada.
Mm-hmm. And Ted, I don't know how deep in the weeds we want to go, but can you talk a little bit about the power flow control technology and actually what it does or how it works to, enhance the transmission capabilities?
Well, I think the key to remember here is you can increase the efficiency of the existing system while planning to and continuing to take advantage of new transmission. It's really not either or. And as I said earlier, individual transmission circuits rarely share power perfectly due to physical characteristics like age, length, conductor type. What our device is doing is it's actually injecting a voltage in quadrature with line current, so in series with line current at a 90-degree angle, emulating what folks might consider a series capacitor or a series reactor, which do two opposite things. series capacitors incentivize transmission power flow onto their circuit, whereas series reactors sort of act as roadblocks, pushing power off those circuits. And, sort of sticking with the traffic analogy, being able to push and pull or incentivize or disincentivize flow along different routes allows you as a system operator to take advantage of underutilized circuits. And so primarily we're looking at thermal constraints. So, a line is demonstrated under an N-1 planning condition to overload, and using our device either to sort of block that or to pull power onto another circuit, we're able to really overall from a system perspective move more power than would normally be able to without having addressed that concern. And I can go a lot deeper than that, but I don't want to lose anybody. So maybe I'll pause there.
Yeah. No, that's great insight, and it helps me at least understand how this technology is working. So Virginia seems to have kind of emerged as a leader, and that may be out of necessity because it is also kind of become a hub for data centers and power demand growth. And so it's developed some regulatory frameworks that kind of support grid enhancing technologies. Have you done any background on Virginia and some of their policies and regulatory frameworks?
So, as I'm sure the vast majority of your listeners know, Data Center Alley began partially because of the connection with the Department of Defense many, many years ago. Then the growth in fiber, the access to transmission, and it was sort of this snowball effect of hyperscalers joining up in that area, connecting in that area, to the point where the stat changes every day, I think, but something like 70% of internet traffic goes through 3 counties in Northern Virginia, which is really quite impressive. I think from a regulatory or legislative policy angle, there are actually quite a few states now that have developed or passed legislation to, I think, really try to maybe not quite incentivize, but at least direct their state utilities to ensure that the system that ratepayers are covering is as efficient as it can be. And some of that stems from trying to build on the work that the Federal Energy Regulatory Commission, or FERC, has done in terms of transmission planning and generation interconnection. But, legislation like requiring annual reporting of grid enhancing technology studies or project implementations. I don't think any state has gone as far, and probably wouldn't go as far, as requiring specific technologies in certain situations. I think, legislators recognize that, as Anna said, these are, detailed technical analyses that need to occur in order to ensure that, the right thing is used in the right place at the right time. But what these bills do is, again, similar to the FERC orders, create an environment where utilities and system operators have the direction, bandwidth, and directed resources towards ensuring that all the whole tool set is being considered at any given time. And I think that will have impact going forward.
What about the economics of grid enhancing technologies? I've got to believe that it's a lot more cost effective to implement some of these solutions than to build new transmission. But are there any actual numbers you can share that would say, it's 50% cheaper, or, costs 10% or 20% to enhance your grid by X megawatts or capacity?
The cost analysis really depends on the time frame that you're looking at. So I think it is hard to say, okay, in every condition, this is going to cost 2 times or X times. It's probably a bit of a fallacy as well. And Ted kind of talked about this. I wouldn't really want to look at, do I build transmission or do I do a grid enhancing technology? The challenge is so vast ahead that the answer is going to be do both. And that's going to be the answer every time. So if you're going to do both, the question then becomes, how long should I install them for? What's their life cycle cost? How much benefit am I going to get in terms of congestion and reducing other costs as well? And then incorporating that in. But there's some places where it's really, really cost effective. I think of it, advanced conductors can be very cost effective if you've got the towers that can hold them. Those towers are in good condition. Then reconductoring is extremely cost effective to use.
Aaron, I would say, typically the traditional infrastructure upgrade could be as much as an order of magnitude higher than a grid enhancing technology capital cost. But the other thing to consider here is opportunity cost. Deploying these technologies potentially years earlier ahead of a traditional network upgrade may actually be the most important metric for a utility or a system operator. It's not quite as easy to quantify, but there are some large moneyed customers, C&I customers, that put a lot of stock in time and speed, particularly now. And I think that these kinds of solutions are going to be considered and deployed far more frequently in that paradigm.
Mm-hmm.
And to what Ted is saying, we've seen examples where utilities are interested in using a grid enhancing technology just to get over supply chain challenges with a transmission build out. So they're thinking about this as, again, like as a bridge, so that they can use these technologies, and then over time they can build another transmission system.
And I'm not a cost recovery expert by any means, but who typically bears the cost of implementing these? Is it something that a utility can put into a rate case, or is it something that requires them to just up their electricity charges for their customers, or if it's benefiting a C&I customer, for example, would they specifically charge that company for these solutions, or how does that work? Or can you talk about that at all?
So I'll say for advanced power flow control, this is a piece of hardware that sits in a substation. Really isn't any, in that respect, isn't any different from the way utilities rate base their substation improvement projects. I recently heard it explained this way: for load connections, which are relatively similar in the way they're treated to generation interconnection, infrastructure build out to directly connect the load facility to the nearest substation. That's generally covered by the development or the developer. Network upgrades, so things that are around this interconnection and are generally driven by this interconnection, seem to be treated a little bit more on a case by case basis. So, a smart wires project that is loosely driven by one or potentially more load connections may be sort of spread, my colleague calls it spread like peanut butter across the overall ratepayer base. And that's done when there's an argument, a clear technical argument for introducing benefit beyond a single or even a group of load connections. So, for example, project that we actually announced yesterday with Pacific Gas and Electric in San Jose is supporting both a specific load connection as well as a regional projected increase in loads here in the Silicon Valley. And so that project or our network upgrade introduces, about 100 megawatts of increased capacity for the system, which is clearly beneficial beyond a specific customer. And so that sort of is treated as a standard PG&E transmission project, and it's it's pretty straightforward from that standpoint.
And are there any technical challenges that still need to be overcome to implement GETS at scale, or have most of those been solved and now it's just getting the technology out there and deployed?
Those technical challenges are at the heart of what we're trying to do at EPRI with our Get Set initiative. We really wanted to focus on those barriers that to large scale deployment. We know there have been pilots. They know that there has been some smaller deployments across North America, more more at scale perhaps in Europe, depending on the technology. And we wanted to make sure that we've de-risked the technologies. And so the biggest barrier that we've heard is knowing how reliable the technologies are going to be. It was really important that for a lot of utilities that there's an objective third-party tester. And to that end, we've built an outdoor test line in our lab in Lenox, Massachusetts. It's really cool. If anyone ever gets a chance to go up to Lenox, you should see it. It's probably the world's most instrumented line. So we were able to test DLR and put it through the ringer in a way that no one else can. I'm picking on DLR, but the truth is we're actually testing everybody. We've been testing advanced conductors for a better part of 20 years out at our lab in Charlotte. We're also testing TED's smart valves. We've got a small unit out at our Charlotte lab. We're going to be putting a bigger one, perhaps maybe two, out at Lenox. And it gets so much excitement. We were all in Charlotte last week we had about 100 people come in to see our lab and to talk about grid enhancing technologies. We talked for 2 days on grid enhancing technologies, to be clear. So you're getting 1 hour of this at most, but it's very exciting. But the other kind of challenge that we also heard, and this is at my heart, I think of myself as a former system operator, is that integration into markets and planning and just knowing how to use the technologies across, okay, not just how reliable they are, but the entire life cycle. How do I plan for them? How do I know that my EMS system is using them? How does my operator know how to use these in every condition that might be on the grid? So that's another kind of technical challenge that we're working on as part of our initiative.
And beyond the technology itself, what organizational or industry mindset shifts are needed to kind of accelerate this adoption? Is there anything that would help in that respect?
As I said earlier, there's an entire generation of utility and system operator staff that, their entire career, the discussion was more around the utility death spiral and, people disconnecting from the grid and a reduced rate base. And this is a totally different mentality. I'm not going to name names here, but I heard someone come up with a different descriptor of the utility silos, the very clear distinction and lines drawn between different teams to make sure that, the overall organization can function. He called them cylinders of excellence, which I've been trying to replicate everywhere I go. But I think to get to your question, Aaron, to me, the mindset that needs to change is it's not just reliability first. It's reliability, affordability, and efficiency. And that needs to permeate across, the entire organization, left, right, up, down. And that's the only way that we're going to transition our transmission system to meet both our load projection requirements and ensure that ratepayers, you and me, don't have undue burden on our bills from specific commercial changes. So that's really top of mind to me. And, I don't think it's a particularly hard argument. Most utility folks I talk to or who, talk about this publicly recognize the same thing. And it's hard, but, strong leaders know how to do it.
I know nobody likes to make predictions, but if you look ahead 5 to 10 years, how do you see the relationship between these grid enhancing technologies and the growth of data centers and grid infrastructure evolving? And what do you see as the future for our modern grid?
There's so many futures to predict. I think what we're going to be seeing is a much greater participation from loads in markets and providing grid support services. I think that that's clear. If you had asked me 5 years ago, I'd be telling you, and I still truly believe that distribution systems are going to play a deeper role. You're going to have distribution system operators. I see that, but I see that also on data centers and on your large loads. There's going to be that engagement that they're going to have. So I think that they're going to be pushing. And one of the things that's perhaps really positive about having hyperscalers and their focus on moving quickly is that's going to get this industry working in high gear. And you only do that by working all together. So I'm seeing that happening right now. Conversations that you probably wouldn't have had 10 years ago, people that probably wouldn't be meeting 10 years ago, they're talking closely now. And that's very exciting. Where that takes us, who knows?
And Ted, from your perspective, I mean, are there new technologies that smart wires might be working on in the background that could be revolutionary 5 to 10 years from now and make a big change and really hit the market in a significant way? Is there anything on the drawing board?
Yeah, well, I have to be careful with my patent officer sitting on my on my cheek here. No, I'm kidding. Anna made an interesting point about distribution. Transmission has certainly been our focus for 15 years, but the same, poor sharing of electricity you see at the distribution level. It's a little bit different because the system topologies look kind of different, but the idea of more local flexibility to manage bidirectional flows that vary significantly throughout the day and are influenced by, local weather systems should introduce a need for better local control. So I think that there's something there. And my CTO has a spreadsheet of like 200 different features and updates and opportunities that is sort of on our longer term list. So if you ask me to predict, I think something in the distribution space could be really interesting that again allows maybe more direct customer control or more neighborhood aggregation. I think it's not a space that I think about too much, and since I'm not a homeowner, I don't get the chance to create my own living laboratory in my house. But someday I think that there will be opportunities there. So that's kind of where my head is right now anyway.
Well, Ted and Anna, this has been a really interesting conversation. I've enjoyed learning about grid enhancing technologies and what you all are doing. And is there anything that I haven't brought up that you think would be important to touch on before we wrap up the podcast?
I feel like you covered everything. I guess get set, let's get going.
I just echoing Anna. We really appreciate the chance to educate. I think these are a class of technologies that a lot of people can get behind. There's certainly natural skepticism around new technology, but the benefits far outweigh the risks and considerations in making time for technologies that increase efficiency. Energy efficiency again isn't sexy, but it's incredibly impactful both on the system and on our wallets. So, I think it's an important topic. And again, we really appreciate your time, Aaron.
All right. Well, thank you both. And again, for listeners, I've been speaking with Anna Lafayanis, program lead for the integration of renewables and co-lead of the Get Set initiative with EPRI, and Ted Block-Rubin, director of business development with SmartWires. So thank you both for coming on the program.
Thank you so much for having us, Aaron.
Thanks, Aaron.